Hello viewers and welcome to today's session. So today we want to know how to determine the total resistance for resistors in parallel. So we are going to consider three resistors in parallel. So let's call this resistor 1, resistor 2, and resistor 3. So for those three resistors, we have a circuit. For each resistor, we can also include an ammeter. We can include an ammeter for each resistor. That means for this one, let's say we have ammeter 1. For this one, ammeter 2. For this one, ammeter 3. Then we have the circuit. We have now the complete circuit. We have another ammeter here. Let's call this 80. Then a switch and 2 cells. So we are considering now this setup. These are three resistors, R1, R2, and R3, which are in parallel connection. So we all know the path of the current when you close the switch here, the path of the current will be through the ammeter 80. But at this point now, current subdivides. So some current will pass through R1 and ammeter 1, another one through R2 and ammeter 2, another one through R3 and ammeter 3. Then it will combine here and come back. So that is the path of the current, and that means current through the three ammeters is not equal. And if current is not equal, definitely voltage is equal. If current is not equal through the three resistors, definitely the voltage is equal. So, but now we are interested with what is not equal. So we form an equation of what is not equal. Remember, our interest is to get the total resistance. So we can say current, which is not equal. So current, the total current is given by current through ammeter 1, that is I1 plus I2 plus I3. The total current will be given by current through R1 plus current through R2 plus current through R3. But we all know, since we know V equals IR from Ohm's law, we all know V equals IR. That means so since we know V equals IR, then it is right to say, because V is equals IR, then it is right to say current is given by, from here, current is given by voltage all over resistance. That's the current, voltage divided by resistance. So that means where we have current here, IT will be VT all over RT. Because where we have current will be replaced by voltage over resistance from Ohm's law. So current total will be V over R, but now TT everywhere. Then I1 will be V. Remember, we have said voltage is the same, so we will not have voltage 1, voltage 2, and voltage 3 because voltage is the same through all of them. So that means we will only have here V all over R1 plus V all over R2 plus V all over R3. So where we have current, we have just replaced V all over R. So, and in that case now, since total voltage is equal to V, in other words, the total voltage across the cells here is the same as voltage across each of the resistors, then dividing through dividing through by V, dividing through by V. If we divide everywhere by V, then we'll have 1 over RT is equals 1 over R1 plus 1 over R2 plus 1 over R3. And that is now the equation to get the total resistance. So the total resistance is given by reciprocal of each of them. 1 over R1 plus 1 over R2 plus 1 over R3. That is when they are 3. If they are 4, we'll simply have 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. Remember, this RT is the total resistance, also known as the effective resistance. And if you want to get the final answer, you will simply find the reciprocal. So that marks the end of that session.